I feel like we can have an emerging technology webinar every week to discuss advances in technology, software, trends, and strategies on how to embrace them, but we wouldn't be struggling for content. There's a lot going on out there. As always, the reason for the acceleration in these emerging technologies is to create our infrastructure faster, with less money, more accurately, and with higher quality materials. It's exhausting trying to keep up, which is why I'm here to help you navigate. First and foremost, you need to adapt to adopt. Your company structure may change from a hierarchical organization to an edge network in order to facilitate the growing collaboration between design disciplines and project teams. You may need to explore cloud-based storage solutions like Panzora to manage the large amounts of data between your offices or remote project team members. Or you may need to modify your mobile device fleet in order to collect and distribute data from the field or access important project information. Whatever the change may be, the time is now to accept that infrastructure technology is going to emerge at an accelerated rate, and your organization needs to be prepared to adopt the changing technological environment. This webinar is focused on emerging technology for infrastructure. And what I mean by that is emerging successful technology. There's a difference between trends and technology adoption. Trending technology experiences a peak very close to the release of the technology. Innovators and early adopters may be applying the technology to a pilot project. They've modified their business models and organizational structure to adapt to the onslaught of technology being presented to them, but that trend may not be ready for the market yet, and the technology doesn't emerge, but instead wanes. Emerging technology is adopted after the innovators have proven the applicable success of the new technology. Some of the risk has been mitigated, and the industry has shown considerable investment in the technology's future. The emerging infrastructure technology highlighted in this webinar is technology you should be prepared to adopt, not the industry's latest technology crush. The major technologies emerging in infrastructure today are mainly focused on the data, how it's collected, how it's processed, stored, used, and managed. The first emerging technology you should be prepared to adopt is the use of unmanned aerial vehicles, UAVs, also known as unmanned aerial systems, to obtain existing conditions information about your infrastructure project. I'm sure you've heard of them, but for those of you who haven't, unmanned aerial vehicles, also referred to as unmanned aerial systems, for all intents and purposes are drones. UAVs are becoming increasingly popular as emerging technology in many industries. The lower cost of the aircraft, cameras, and software, coupled with the increased processing speed, cloud computing, and flight autonomy, has accelerated the adoption of UAVs to create an existing conditions model, or they're used for site inspections during construction. LiDAR and photogrammetry is gathered through the use of a high-definition scanner or camera mounted on a gimbal from the aircraft. The UAVs can be remote controlled, or they have their flight paths automated, as seen in this video. Once collected, the information is then stitched together using software such as Autodesk's Recap 360 Pro, which will produce point clouds or models of the information. This emerging technology is also becoming increasingly popular for developing planimetric features, volumetric surveys, pollution modeling, urban planning, coastline management, oil and gas exploration, and archaeological surveys necessary for federal environmental studies. This technology allows existing site conditions to be recorded and modeled in hours instead of days, and can produce more accurate data than traditional ground surveys. In my experience, surveyors are very particular about their topographic surveys. With the advancement of BIM and pressure to adopt BIM for civil infrastructure, skepticism abounds. Almost a year ago, a study was performed by Macintosh Perry Surveying Incorporated and UKKO, a Canadian mining and surveying firm specializing in UAV aerial topographic surveying. The task was to compare the horizontal and vertical accuracies of ground RTK GPS survey to UAV surveys. The field topographic survey resulted in acquiring approximately 1,800 data points over a 100-acre site. Each point had X, Y, and Z coordinates, and a digital terrain model was produced. Field accuracies were observed to provide results between 3 and 8 centimeters in each of the 3 axes, over 95% of the observations. The combined accuracies averaged between 5 and 6 centimeters, with an acceptable level, which is an acceptable level for subdivision development with drainage modeling. In the same year, a fixed-wing UAV was used to conduct an aerial survey. On board the UAV was an 18-megapixel camera, allowing for 1 pixel to equal 3 centimeters on the ground when flown at a distance of less than 400 feet. The unit collected over 31 million points in 4 hours, which included setup and setting and targeting the ground control points. The flight time was less than an hour. With UAVs conducting aerial LiDAR survey and photogrammetry surveys, the process and management of survey data will experience a major shift. The point clouds, meshes, and 3D solids will be referred to in lieu of returning to the site for additional field observation. The collected data can be edited and transformed to be used as a terrain surface for watershed analysis and site planning. Recap 360 Pro allows users to obtain measurements and accuracy reports directly from the software, as well as the ability to import ground control points and process photogrammetry obtained through UAVs. The collected data is of higher quality and is obtained faster, resulting in reduced project costs due to acquisitions and accuracies. So what we're seeing is how AutoCAD 360 Pro's workflow works with the additional softwares in the suite. So this site was surveyed using a UAV, a point cloud was collected, and what we're seeing now are takeoff and measurement calculations. This video also demonstrates the scanning of the cavern, and what we can do is produce these pretty high detailed meshes which can be used for renderings as well as surface creation. Recap 360 Pro provides a lot of interoperability and a lot of options for processing the point clouds before bringing them into other softwares contained in the workflow.